Ladies and gentlemen, Ricky Lewis.
Well, hi, I'd like to thank the planners for inviting me to this wonderful event today. I'm a geneticist and a science writer, and I think this talk will be a little bit out of sync with some of the others. I'm sort of an outlier. My professional story really begins in 1980 when I got my PhD in genetics for making flies that had legs growing out of their heads. And I managed to be lucky enough to get an assistant professor position right out of graduate school at Miami University. I'll never forget interviewing there because there were 3 criteria that I fit. I was under the age of 100 because the faculty was very old. They needed somebody to teach genetics, several classes of genetics, and to do research, but more important than either of those, I had 2 X chromosomes. There were no women in the department. When I arrived there, my picture was taken everywhere I went because it was such an anomaly to have a woman in a science department. Yet when we had faculty meetings to go to and social events, the men with the PhDs were doctor, and me with the PhD was Mrs. So this was 1980, those things happened. Live with it, right? So I was very happy at Miami University. All those older men treated me like a daughter, and it was just terrific. After I'd been there about a year, there was one afternoon when I was holding office hours with my door open, nice and friendly, and all of a sudden, almost every door on my hallway slammed shut. And I didn't know what it was, a fire or something had happened. And I walked out into the hallway, and there were men in suits walking around, like they didn't know where they were. And this puzzled me because professors don't wear suits. Especially biology professors are amongst the worst dressers on the planet. So I knew that these men in suits couldn't possibly have been, anything to do with biology. It turned out they were an extinct species called acquisitions editors. They were representing textbook publishers. Editors and publishing houses are no longer called editors, they're called brand managers. So the editors were trying to find professors stupid enough to sign contracts to write textbooks. And everyone else being more experienced than me, I was 26 and 9 months pregnant, had slammed their doors, I invited them in. I had 5 publishers offering me contracts that were lined up waiting for me to sign, and I think part of it was because I had a bulletin board with all these magazine articles. I had been writing for the Cincinnati Enquirer at that point, and I covered a lot of breaking medical news stories. I actually do that now for other places, so I haven't really grown all that much. But I kind of signed my life away. They all wanted me to write an intro biology textbook, and I didn't want to write that. I wanted to write a human genetics textbook. Every one of them said, genetics? That's not important. Nobody cares about genetics. So I didn't write the genetics book. I wrote an introductory book called Life, which is now dead. So that was 1980. In 1985, there were rumblings in the scientific community about starting a project that would become known as the Human Genome Project to decipher the genetic instructions of a human being. I went to one of the very first meetings. It was in Boston in 1986 to discuss this. The government project started in 1990 to sequence the human genome. It was completed by the year 2000. In 1994, a company called Celera Genomics entered the race, and they actually knew more what they were doing, and they actually they beat the government people, but that is not widely known. But that first human genome sequence took 10 years. Does anybody know how long it takes to do it today? Anybody want to guess? 22 hours, the last I heard. It's probably even faster than that. So things have really changed dramatically. Now, I went on to have a very good and successful career writing a lot of different textbooks, and over the past year, I sort of have a year off in textbooks because it's like planets aligning. We have an astronomer here. Because every once in a while, the editions don't overlap, so I get a year off. So I've been writing news a lot for a lot of the medical journals. And when I was asked to give this talk today, I started to think about how I think we're going too far with a lot of the new technologies. And I keep going back to that great scholar, Ian Malcolm, who was the mathematician in Jurassic Park, who said something to the effect of, even though we can do something, maybe we shouldn't. So I'm just going to give my talk really fast. It's 7 things that I think we ought to think about a little bit more before we start doing them. The first one is DNA and dating. I write a weekly blog for something called Public Library of Science, and I did a post called DNA and Dating because I found this company where spit into a tube and mail you your spit, and do it with your partner, they'll tell you if you're compatible. So I did a little bit of they referred to a couple of papers in the medical literature that were valid papers. The first one was to do what's called HLA typing. Those are the genes that determine whether you get a blood transfusion from somebody without dying, basically. And their website said it would be really good if your partner had the same HLA, genotype as you do, which I thought was really stupid. And that would be very helpful if on, say, your 4th date you suddenly needed a liver transplant. Right there. But it would be really bad if you had an infectious disease, because if your immune systems were the same and you got a horrible plague or cholera or something, chances are you're going to catch it from your partner. So I just objected to that. They only detected 2 different traits out of the 20,000 or so. The second one had to do with the serotonin transporter gene, which has to do with neurotransmitters that are involved in depression. So they did have a citation. I looked up the paper. It was a study unblinded on 32 people that had something to do with whether they could predict whether their marriage would last. I don't know what this had to do with anything, but they advertised it as if you're going to go out with someone, you can find out if you married them, if you would get divorced or not. So I published this blog. I didn't name the company because I didn't want to get sued and I didn't want anyone yelling at me. And sure enough, I got a response from a different company offering for Larry and I to spit into tubes and find out.
I'll tell you the results afterwards.
Okay. I made him get his Y chromosome checked once and he found out that he was an Ashkenazi Jew, which of course we already knew. I'm not big on DNA testing, as you can tell. The second thing is egg freezing. This was suggested by Facebook and Google about 6 months ago, supposedly as a way to enable women to freeze their eggs and then get pregnant when they're 60 and have kids later on. It was a way to increase productivity. It can cause infertility, cancer, and death to the woman and the eventual embryo, so it's not a great idea. And of course, the first thought that occurred to me was if this involved some kind of tinkering with the male sexual apparatus, do you think they ever would have suggested that? Shouldn't be done, and it's unnecessary. Okay, this one received a lot of press, and I've written quite a lot about this. It's really fascinating. If anyone remembers 10th grade biology, the mitochondria is the powerhouse of the cell. It's an organelle. Each cell has a few thousand of them. The energy reactions take place there. The mitochondria have their own genome of 13 genes. It's tiny. They're dependent upon 1,500 genes from the nucleus. But if you've got a mutation in one of those 13 genes, it's a very devastating disorder. It's a little too complicated to go into, but it's passed from mothers to offspring only. Because when a sperm goes into an egg, it leaves its tail in the mitochondria sort of on the outside. So there's this technology where you can take a woman who has a kid with a mitochondrial disease. You get her egg out, which probably hurts. You take out her, nucleus, and then you stick the nucleus into the egg of a woman who doesn't have a mitochondrial. It's complicated. It's like smushing together 2 eggs, basically, to make up for the problem. And that leaves you with what ethicists call 3-parent embryos or babies, which is, that's a big grain of salt there because it's only 13 genes that are coming in from the donor egg, whereas there are 20,000 from the other one. But it is in the headlines a lot because it's causing a 3-parent baby to form. This is being done in England. It's not being done in the US. And when it comes to reproduction, things are usually done in the UK. We yell at them for a few years. Then we gradually realize it's a good idea. And then about 10 years later, the US starts to do it. So that's the way reproductive genetics usually works. But I did listen for 8 hours to a meeting at the FDA to evaluate this technology a year ago. And basically, it's not needed. At the meeting, a woman who was very, very disabled because of a mitochondrial disorder got up and she summarized everything and said, instead of tweaking all these eggs and sperm, why don't you help me? Why don't you use all this money to help the people who are suffering now? So that kind of summarized that technology. So I think a lot of people agree with me that it's not really needed. This one has been in the news quite a bit for the past month or so. It's a technology called germline editing or genome editing. It has a whole bunch of names, but it's actually called genetically modified humans, and I usually hate hype, but that's kind of accurate. This technique, which is called, it's a very bad name, CRISPR, that's an acronym, I can't even remember what it stands for, but it's basically replacing a gene. But next generation. It's not like injecting something in someone's earlobe or foot. It's changing the germline, and that's what people object to. I think it was just last week that the National Institutes of Health banned any federal funding for this type of research in the U.S. But the Chinese did it published it about 2 weeks ago. They actually did what I thought was a very clever experiment. They took in vitro fertilization leftovers. They were fertilized over that had never ever developed beyond a couple of weeks because they had 3 sets of chromosomes. And they tinkered with these embryos to see what would happen. And basically it didn't work, but it could work. And it's supposedly very, very easy to do. So there's a lot of talk about genome editing and how it shouldn't be done because it can affect the next generation. And when you do the genome editing, a lot of these manipulations can't be done on a fertilized ovum because you would destroy it in the process. So you have to do whatever you're doing. You let it grow up to the 8-cell stage. And there's a characteristic of most animal embryos that at the 8-cell stage, you can remove 1 cell to look at it and put the other 7 back in the female, and it'll keep developing. So when you do something to fool around with a fertilized ovum, you let it go to 8 cells or 16 cells, you take out 1, look at it, and if it's okay, you put it back in. So that's basically how it's done. And when these studies talk about embryos, they don't mean cute little baby things. They mean balls of cells, so there's a little bit of emotion involved when anything involving an embryo is discussed. The problem with using this technique for anything other than basic research of just cells in a dish is that an embryo probably couldn't survive very far with this sort of huge manipulation. And there are what's called off-target effects. You can try to swap in a gene at one point in the genome, but what if it swaps in at 80 points? What is that going to do to other genes that it jumps into? It's probably not going to be viable. It will probably lead to new mutations, and you can end up with mosaic embryos where, say, 20% of the cells have the alteration, 80% don't. So the intention of the technology is good. It's to prevent illness, but it actually doesn't make a whole lot of sense to me, and I use stop signs on all these different things. I love pre-implantation genetic diagnosis. It's a great technology. It's sort of what I just described. When you use in vitro fertilization, you let it go to the 8-cell stage, pluck out a cell, test it. If it's okay, you put it back in. If it's not okay, then it gets a little iffy. A lot of those not okay embryos, they can be destroyed, they can be frozen, or they can be used for research to actually learn something. I remember very clearly when the first cases were done. The first case of pre-implantation genetic diagnosis was a little girl named Chloe O'Brien, and she was tested as an embryo to make sure she didn't inherit cystic fibrosis, which her brother had, and I remember the parents being on the Today Show and getting yelled at. That's what happened. My slide here is a little bit off. The next kid's name is Adam Nash. He was conceived so that his umbilical cord stem cells could be used to save his 6-year-old sister from something called Fanconi anemia. And he was a tissue match for her, and he was helping, he saved her life. And it was the basis of a Jodi Picoult novel, although she got a lot of the science wrong. But the Adam Nash, I remember his parents from Today Show, and they were just vilified for what they did, and now it's almost routine. In New York City, when women have IVF now, they always have the embryos checked because they don't want to put an imperfect embryo inside the woman. So it's kind of started out being used to help avoid a disease in a family. Now it's routinely done for sex selection. And in some countries, overuse of this technology has led to skewed sex ratios where female embryos are not allowed to continue development, which, as we learned from what happened in China, is going to have repercussions in a generation. So I think this is a good technology when it's meant to prevent harm. I think it's a bad technology when it's meant to prevent females from being born, obviously. 6 is testing fetal DNA. I have a lot of mixed feelings about this one. The first fetal genome was sequenced in 2012. I don't know if that's widely known. It's done because there's fetal DNA in the bloodstream of pregnant women, and it's much safer to test for fetal DNA from a woman's arm than it is to do amniocentesis and chorionic villus sampling, which are the standard techniques that are close to becoming obsolete because of this new technology, which hopefully will be the subject of my next book. I've gotten really into this. So these tests have been available since the end of 2011. They will weed out women who have healthy fetuses, don't need to go on for the more invasive ones. But the question is, when we go on to sequencing entire fetal genomes, what should you tell the parents to be? too much information. You're getting tons of information, and you don't know how much is going to be helpful to the individual. It also can be used to select trivial traits. And the seventh one is newborn genome sequencing. There are experiments going on in 4 major medical centers now where thousands of newborns are having their entire genome sequenced. And I wrote a couple of blog posts about this, creating a generation alpha. If you think about the entire newborn generation being sequenced, just like there's newborn screening for a few dozen tests now, we'll have a whole cohort of the population where they know everything you can possibly know about your future health, and there are tremendous implications for that. So it's good because it will lead to diagnoses. It'll prevent people spending years getting diagnosed, but it also creates a situation of patience and waiting where the parents are constantly nervous about what's going to be. And I just wanted to end with asking you the question, would you want to know your own genome sequence? It's going to be under $1,000 pretty soon. It takes less than a day, but a few weeks to analyze, and I was offered the opportunity to have mine done, and I turned it down because, for every Alzheimer's disease gene that increases your risk, there's another one that decreases your risk, and until we know what all the genes do to each other, I think it's premature to be sequencing everybody's genome, but it is being done. It's being stored on Google Clouds, and kind of the cat's out of the bag. So that's just a summary of everything I do. I do write textbooks all the time. The one in the middle is a textbook. The one on the left is my narrative nonfiction book about gene therapy. The right one is a short book I wrote to get around the high cost of textbooks, and instead somebody stole it and put it on the internet, so I never made any money from it, so I tried to do a good thing. That's what happens. I write the DNA science blog every week. I wrote for the Journal of the American Medical Association, but didn't get along with the editor, so that ended. And I write about 3 times a week for Medscape Medical News, which is a professional arm of WebMD, and I love writing for Medscape. That's what keeps me up to date on everything. And there's someone holding up a big number 2, so thank you.
Opportunity to answer any questions that might have come up from your presentation.
So I think you called fetal DNA, your number 6.
Yeah.
I wasn't aware that fetal DNA was in mom's bloodstream and that you could test that way. When I was pregnant with my children out 9 and 4, that wasn't an option or not an option.
No, it wasn't. That's what I'm writing the new book on.
And I'm curious. I always avoided any testing to determine the health of the baby outside of the ultrasound because I wasn't going to do anything with that information anyway. But also because there were risks to the baby. With this new testing, I'm curious. For example, with the old testing, we only give you a probability. There's a 1 in 10,000 chance that X will happen, and that just wasn't enough information, actionable information to me. What are the new results like?
It's pretty easy to explain. In fact, when I was pregnant 3 times, I did the exact same thing you did, although I'm a genetic counselor. I only had ultrasounds too. But the new testing, it's called a screen, not a test, because it's not diagnostic. If you're negative, meaning that you don't have an extra chromosome, you can relax, not take the amnio, it's fine. If you're positive, the false positive rate is close to 50%. So if you're positive, no, don't shake your head. It's a statistical thing. I spent 4 hours yesterday doing statistics. It's 50%, but that's 4 out of every 10,000 women having it. These things are really, really rare. So if you get a positive result on these new tests, then you have the amnio. So it's going to save a lot of lives by preventing people having amnio who wouldn't really need it, and the amnio is itself risky. And the woman who invented the technique continually gets death threats from anti-choice groups, from disabled Down syndrome groups, and they don't understand that the technology is going to save lives. It's not going to, hurt them. It's going to be a lot safer. But yeah, those are the other tests that are in place to follow the big
From this side of the room.
Hey,
Yeah.
hi. Are there any predictive genetic tests that are highly accurate?
Oh, yeah, there are. There are plenty of them.
Okay.
The one that is the most accurate, unfortunately, is Huntington's disease, which is absolutely horrible. And that mutation is really weird. It's an expanding repeat mutation. There's a ZAG over and over. And the larger your gene, the worse the disease is going to be. So that's nearly 100% accurate.
many outweigh the needs of the few. Why not invest in this to prevent the disease in the future rather than devoting the money to the people who have it?
Well, that's a good point of view. I just think it's too dangerous and it's too onerous, and I think it would cost a fortune. So I think for every case that you prevent, you could probably help about 100 or more people who are already sick with it. So yeah, I could argue both points for that.
Dr. Lewis, I really hate to do this, but again, please follow her blogs. I love your work. I'm so glad. I want to thank you so much.